let's assume that we have an electron, and this electron is moving at a constant velocity. The constant velocity is 4, 0, -4 meters per second. And this is simply the x, y, and z component of that particular vector being the velocity. Now we already know the initial position. Our initial position is 3, -2, 0 meters, and that is at 30 seconds. What we're looking for is the position of our electron at 60 seconds. Now we can do this simply by plugging in our numbers to the position update formula. However, if you take a look, you can kind of conclude on your own which components of this vector are going to change. And you can look at it by looking at the velocity. As you see, the x component is changing. Therefore, in our final position at 60 seconds, our x component should be different than our initial position. Also, the y component is 0, which means there's no velocity, there's no change in meters per second. Therefore, our final position in the y component at 60 seconds should be the same as the initial position, which is -2. Again, -4 is our z component, and it is moving. Therefore, the final position at 60 seconds should be different than our initial position. But that's all just hypothetical, looking at the velocity, what's changing, what's not changing, and concluding what may change in our final position. But let's work it out. So the position update formula is R2, which is what we're looking for, is equal to R1. We know R1. It's right here, 3, -2, 0. And our initial position plus the average velocity multiplied by the change in time. Now the change in time is very easy to find. Change in time is simply the final, so time final minus time initial. And that'll give us 30 seconds. So 60 minus 30 seconds, which will give us 30 seconds. So let's plug it all in and see what our final position is at 60 seconds. R2, what we're looking for, is equal to 3, -2, 0 meters plus the velocity, which is in meters per second, multiplied by the change in time, which is 30 seconds. And you can see algebraically our seconds are canceling. That leaves us with a vector plus a vector. And legally, you can do this. Mathematically, it's okay to add one vector to another vector. Completing the equation, our final position at 60 seconds is and as you can see, this y component of our final position is the same as the y component in our initial position. This is because our velocity is not changing.